Welcome to MathXara.
In today's video, we will prove a trig identity. We'll prove the left-hand side to be equal to the right-hand side. 1 minus sine x over 1 plus sine x. And we're going to multiply this by 1 minus sine x over 1 minus sine x. See, it's the opposite sign of our denominator. Now, if we take a look at the difference of two squares, which says a minus b into a plus b equals a squared minus b squared, which resembles our denominator, 1 plus sine x into 1 minus sine x. Let us FOIL our numerator. So we'll do 1 times 1, 1 times sine x, negative sine x times 1, negative sine x times negative sine x, which would be 1 minus sine x minus sine x, and negative sine x times itself, that's a positive sine squared x. Now for our denominator, which is the difference of two squares, that would be 1 squared minus sine squared. Let us simplify this a little bit further. 1 minus sine x, that's minus 2 sine x, plus sine squared x. For our denominator, let's take a look at our second identity. Now, if I subtract sine x from both sides, or sine squared x from both sides, I'm left with cosine squared x. So my denominator should be just cosine squared x. Now, let's write this fraction as 3 separate fractions. The first one would be 1 over cosine squared x. The second would be 2 sine x. And we're going to write this cosine squared x as cosine x times itself, plus sine squared x over cosine squared x. Let's take a look at our third identity, which says that secant x equals 1 over cosine x. If we square both sides, the identity still stays valid. So 1 over cosine squared x could just be written as secant squared x. Now here we have sine x divided by cosine x, which here in our fourth identity is just tan x, which leaves me with 2 tan x divided by cosine x, and sine squared x divided by cosine squared x would be tan squared x if I were to square this identity, square both sides. We're almost there. Let's rewrite what we have so far. Now, if you notice, there's a cosine x in my denominator, which technically is 1 over cosine x, which we do from before is secant x. Now for our last identity, which says a squared minus 2ab plus b squared equals a minus b, all squared, which is a perfect square trinomial that's actually factored. So if I take secant x to be a, tan x to be b, this should yield secant x minus tan x, all squared. Let's fix this up. Which is exactly what we were asked to prove.